Right, this tutorial is a quick introduction into QGIS, which is a freeware, free and open source geographic information GIS system software. I'm going to keep it to a specific aspect of QGIS, so we're really going to drill in on is spatial and aerial and different data related to that nature, photogrammetry with orthometric fixes to coordinate systems. We're going to go into that today for downloading. We've used many systems in the past at our company in particular. TopoDot through Bentley is one. I've used Plex Earth through a CAD plugin. I've also used Global Mapper a little bit, as well as other folks. And they all are very handy in certain ways. They all have very expensive paywalls. They're expensive add-ins. They have a huge value added. But this is an introduction to QGIS, how it can add some of the same value for free using uh, Python scripts and other various freewares that have been developed. So let's start with downloading the most recent version. I have a different version installed. It is looks like QGIS Desktop 3.22.8, which in this case will work fine for our purposes. That's the one I have open and I'm going to use right now. I have an older version here. I have some other softwares. I'm going to just bounce in real quick. TopoDot 11.5 from 2018 that runs through Bentley, just to show you something we've used in the past, just briefly. But we're mostly going to focus on QGIS and getting aerials and base map imagery so they can mesh with our projects, make nice mapping. Anyone can use these. They're very repetitive, useful tools for surveyors, engineers. This doesn't have to be a paywall type thing, specialized little hole that only two people know. It's very, very easy to do once you have it set up. So let's download, get that going. I have this version installed. Looks like 3.28 is the current version, version Buenos Aires, and July of 2020 this is taking place. So get that downloaded, install it, restart it. The next step is you go into here to download now through qgis.org. It'll take you here. Look for the most current versions, standalone versions. I have this version installed, which is fine. You could try the 3.26 is fine, and get that going. And the next thing you're going to need to install is a plugin within QGIS. It's a little bit hard to track all this down. It's called Quick Map Services, and since it's a freeware program, there is information available. Here is generally the website. Well, is the website if you really want to find it. The plugin you'll need to download. It is plugins.qgis.org, plugins, blah, blah, blah. Quick Map Services. So you can Google some of this. Here's the latest versions. Looks like we're on 0.19.29 this March 2020. Download that. There's one thing I want to show here. Here I have 3.22 open after I installed it. And this is a file I saved to our network, which we'll go to that later. A quick intro, it's a little weird to install a plugin, so download the Quick Map Services. So download QGIS latest version first. Next, download the plugin Quick Map Services to wherever location. I have on my desktop here. And when you open QGIS, you'll have to go into plugins, install from zip. There's probably other ways to install it from a cloud, but this is the way it worked for me. And then install it from this zip file. A little bit confusing there, but that's what I did. And then at that point, your add-in Quick Map Services will be right here in plugins. You can manage and install. You have it there. More easily, it is right here. Web Quick Map Services. Here's all your services of open source. This open source software seeks out Esri, Bing Maps, USGS Maps, NASA Maps, Google Maps, which I use quite often. It'll probably bring a toolbar in here as well with the Quick Map Services. It should. You can also populate these toolbars this way by right-clicking. Very typical in a lot of programs to turn on and off the QMS is the acronym. Turn that on and off. So look for those things after you install to get it running. The next step is let's make a project. So let me open up, before I open up my base maps, Let me make a project and say project new, or hit this new button, similar. And we still need to give this new project, it's a blank slate, some properties. So go into project properties and go to CRS, coordinate reference system. All the reference systems of the world. Here's recent ones. I use this for Montana. We'll just stick to this one. NAD 83 2011 instance of state plane coordinate system. And a lot of times my colleague Bill told me he searches by the numeric number of the coordinate system. That helps. I hit enter when I shouldn't have. Let me go back to properties and let's just do a search to see what comes up. There's plenty of other things you can use this search for. You could type in Montana. It shows all the old datums and projections and instances of these coordinate systems. So I'm just going to go back to the 2500. In this case, we'll pick this more updated one over this state plane one in this case. So we'll pick our coordinate system. We'll hit apply. We'll hit OK. Now that's set. Now we're ready to get our aerial imagery imported. So let's go to some of our options here. Let's turn on Google Hybrid. I oftentimes will start with that so I can find myself on the map using state boundaries, highways, whatever it has to be to orientate myself instead of just a straight aerial. Let's just pick a city randomly. I'll pick Harlowton. Say I want the whole city for some big overall feasibility study and I want to mesh it with some quick drawings. It's a good use for something like this. And I'll turn it down now in my quick map services to Google Satellite only. And on my left here in my layer state, I have to turn off hybrid. So I have two options now: blank, hybrid, satellite, both. Now let's get it to kind of where I want to have my bounding box. Let's zoom out a little farther than I want, and you'll see why in a sec. Let's go about here. I know I want to get most of the city extents, let's say here. So I feel I have that. I'm going to go to project, import, export. There's probably other ways to get to this. I'm still learning a lot about this program. This is the way I've first learned. You go to export map to image, PDF or DXF, a simplified CAD file, but we're going to go to image. And here's some of our main controlling factors in this area. Most of which, there's three ways to make your bounds. Calculate from layer, map canvas extent, this whole extent where you're at, or draw rectangle. So these three here, okay? Now, the second layer of control, or major level of control, is how much resolution on the aerial. And this can be tested out. 96 dpi, dots per inch, is generally for your computer screen, but from what me and some of my colleagues have been finding out is we'll do it at 1,000, and this controls how zoomed in and how much resolution the aerial is going to have. We've gone up to 2,500 plus before. This is the controlling factor on the size of the file. You can see the pixels go way up. So let's do 2,000 here, hit enter. Sorry, I didn't want to go that far. Avoid hitting enter. Let's go back to project, import, export map to image. And let's just click in a dialog box. Let's say 3,000 here. We click here. You can see the pixels go up, which is going to be the biggest impact on my file size. And you got to kind of experiment with this. This takes a little getting used to what you need, how big your project, how zoomed out, what kind of file you're producing for printing or whatever. This is one of your bigger factors right here in your size. I'm going to choose the third option of the three to draw on canvas. I'm going to draw a rectangle to get my northing and easting extents. Draw on canvas. You got a left data click, pick and hold. That's the rectangle. It updated my coordinates on both or all four cardinal directions. Then we're going to hit save. Let's pick a spot where we put this aerial. Obviously, if it's project related, put it where it needs to be. The TIFF, everything in the metadata is self-contained. TIFFs are bigger than JPEGs. They're less, not condensed is the wrong word. The data is bigger and less compressed. There is no ECW option. We'll survive, but that's just, there's some limitations. There's other image options. PNGs are generally good for web pages and stuff. JPEGs are a little more compressed. BMPs we don't use a lot. There's several others. TIFF I would go with to start. They're bigger than ECWs, but they're very friendly in CAD. You can chop them up in different pieces. So let's just call this my project number underscore Harlowton. I'll put the state plane coordinate system, Montana, for example. This is really helpful just for people jumping into the file. And I might put a date, downloaded or something like that, a month. And I'll put my initials at the end saying I did it. You can also find that in the file information, but that's generally what I'll hit save. It starts to show the status bar here. Wait till the status bar is done. You can watch where it's saving. I'll go to my desktop, for example, and it's still thinking. It hasn't produced a file yet. I don't see it here yet. So that is another indicator. Let's go back to QGIS. It's still going. When this ends, the file will be populated to TIFF. When it ends, it shows a little green box come up here and it disappears. It's ephemeral, it's temporary, but that comes up. It's the status bar is done here. And obviously you can go to where you specified to download it and it's available. Let's double click on it, open it, take a look. There's Harlowton. It has metadata within this TIFF file. Hit X to close this. Let's take a quick look at the size of this thing. It's probably a ½ mile by a ¼ mile rectangle, give or take. There's its pixels and size. It's a fairly good sized image, ½ GB. So be very surgical on what you need, what size, maybe break it into a couple. The size of your files can have your image files can have a big impact on your CAD files and other files down the road. And it is a critical path to think about for people downstream of your project. Moving on to a quick side note, our global mapper and TopoDot, we've used a lot of TopoDot in the past through MicroStation V8i or SS4, which is Bentley MicroStation and OpenRoads 2016 version. We've loaded aerials through databases here, which has been pretty handy. They come in as tiles. We can change the resolution. And then we bring the tiles into Global Mapper. And Global Mapper does some of the same things, but these are all different versions and different ways to do what I just did in QGIS. They're much more thorough and expensive paywalls, sometimes a little more complicated to install the software. So that's just a quick pass on some of the methods we did. TopoDot was one of them, which is still an industry leader, and Global Mapper as well. So let's take this image and put it into CAD quick now. In this case, I'm just going to be in 2018, Civil 3D or AutoCAD. I'm going to hit Q new or new. It should go to your survey template or whatever template you're linked to that is live and active. This is a good way to start. We'll go to model space to get ready. And this is very relevant to currently. We've seen a lot of errors when coordinate systems are set up with the map I insert command likes to scale to seemingly random amounts, which has been a problem lately. But oftentimes when you start with a blank template or a full blank AutoCAD file, this issue is eliminated. The way it populates seems to be when you set a coordinate system. So let's set if we set our coordinate system, what I mean by that is we have to go to drawing settings or edit drawing settings. There's a few ways to get here. You want to put a period here to wipe out whatever coordinate system you have. If you have blank template, this will not be set, no datum, no projection. That's what's been causing this error when you pick a coordinate system. I have not figured out why or how that's happening. It might not be happening in the newest versions of Civil 3D. So we pick a coordinate system like Oregon, for example, maybe NAT 83. US foot south zone. Once this is set, that's when the error comes. And you'll know right away with that error that it will be scaled massively bigger than it should be. You can just pick the size of a building or a road and it's going to be way off. So let's just keep this as no coordinate system. Put a period there to just get back to it. We'll hit OK. Also, you can right click to repeat. Let's go back and check it again. So this is what it should be set at. And also in drawing units, here, when you change the coordinate system, the drawing units change with it. Now, you can change the units after you change the coordinate system, which is a bad idea. You should let them change at the same time. You can physically go in here and change this to what you don't want. Right now, it's set to US survey feet by default. You can change it to international feet or US survey feet. So we'll leave that alone, but just note to not mess with that after you have changed your coordinate system. So we're going to import this image. In this case, we're in Montana, so this needs to be international feet. That's potentially something that will need to be changed in the template soon because we're going to only international feet across the US. Next step is, I don't have it in my menu bar at this time, but the alias for the command is map I insert. So 2 I's in a row. You can start typing anything and it populates. So let's go there. This is how we're going to bring in this ortho image. And let's go to it that we just produced. Desktop in this case. There's my Harlowton image. Let's hit open. In most cases, this is going to be in meters. So it doesn't have any scaling issues between metric and US. So this is the error we've been seeing. This scale should be 1. In insertion, this scale should be 1. No idea what's causing this to go to 5,000, 8,000, whatever random numbers that populates. If you see this as a number, that's a problem. Try to get it inserted into a clean file or template. Let's bring it in. You can see there should be data here, an insertion point here. That's the metadata inside the TIFF file. Let's hit OK. I'm going to double click in the middle or type in zoom extents, or you could go to view, zoom up here, options, extents. So that image file is way off into space over here. And there we go. You want to check it with whatever GPS data, any real survey data. You want to vet what you can to check and see if it's spatially correct. You might want to check one distance, maybe of a road, to see if it logically makes sense. It didn't scale it up. That looks about right, about a 32-foot road. It's not 5,000 feet. You didn't have that scaling issue. Check it with whatever you can. Even you could check it with geolocation, which you'll have to set a coordinate system for that. In the background, you have to go to Montana 2500 to check it with that, is one option. But preferably, check any aerial with any real accurate survey data you have in your drawing, whether it be from a cloud or GPS or total station. That's going to be your best, safest bet. Now this aerial inserted is on it's an XREF, it's an external reference, and it's path to my desktop in this case, which is an ideal. Path it to where you go on your project, of course. So there it is in there. It's on its given layer. Put that accordingly. But most importantly, more than anything, if you see something that's off or wrong spatially, nitpick it, check it out, get some help. Ask someone if you missed a step in the process. Maybe the data you downloaded, some setting was switched. There's all kinds of little things that could be pitfalls. Just ask someone else to help you out if you're seeing any discrepancies in how your aerials come in. Last thing, I just want to show where a lot of things are here. If we go to our high level, we got all of our survey department stuff is synced to it's all in the cloud, the vast majority of it, except for certain TBC files. just remember to sync it through Teams or SharePoint. Let's go into the high-level survey department. We're going to go, a lot of this stuff is going to be contained here. Where I'm going, we'll go to training. And a lot of this stuff, like I'm doing here and other various things related, office software. We have all of our office software for training related stuff, and this will be in QGIS. I'm going to populate and put this video here and also other screenshots. This was the one screenshot, for example, how to install that, get that plugin started, Quick Map Services to begin. Now there's more to explore here. And here we go. This is just connected to my OneDrive. So anything we used to have on our servers, it's now here. I mean, we all know this, but just getting used to going here to our synced survey department high-level general documents. So that's it for now. I think the next time around we're going to explore some options to see if we can download any topography or other various data, high-level data to use out of QGIS.